In this video, we're going to be solving this circuit problem using mesh analysis. So the problem says find the voltage Vout, which is right here, using mesh analysis. So pretty straightforward. So to start with the basics, to use mesh analysis, we need to know KVL, or Kirchhoff's voltage law. So KVL tells us that the sum of all the voltages around a loop are going to be equal to 0. So that's pretty basic, but we'll see how this applies when we get into the problem. And for this problem, I'm going to be using the passive sign convention, which means that the resistors are going to have a positive sign, but that'll make more sense once we get into solving the problem and see how we do it. But just remember, the most important thing with sign conventions when solving circuits is to be consistent. So let's just jump into the problem and start by defining our meshes. When I look at this circuit, I immediately see 4 meshes, so I'll go ahead and label them in red. And I'm going to call this one right here I1, this one right here I2, this one right here I3, and this one I4. And I always do them in the clockwise direction. I draw my meshes. You can do them the other way or go back and forth. I just find it easy just to always be consistent going in the same direction. With that, we can start writing an equation for each of our meshes. The first one, I always start in the bottom left corner. We're going to go around the I1 loop. So starting down here, we go up through this resistor, and I said that resistors are going to be positive. So the voltage across that resistor, V equals IR, is going to be I1 times 5. And then if we continue around that loop, we get up to this 2 ohm resistor. So that's going to be 2I1. And then we see this current source right here in the middle, and we don't know what the voltage across that is. So I'm going to go ahead and label that. And I'm just going to call that VC for voltage across the current source. When we come to this source, you see that I put the positive sign up here. We're coming around this way. We see the positive signs first, so I'll put a positive sign here, plus VC. And if we continue around the loop, we see that there is no voltage here. It's just a wire. So that's all the way around our I1 loop. So we know that must be equal to 0 according to KVL. So then we can write out our I2 loop. Starting at the bottom left corner, we're going to go up this way, and we see that this time we hit the negative sign of VC first, so I'll write that minus VC, and then we come around to the right over here, see the 3 ohm resistor, and I said the resistors are going to be positive, so plus 3I2, and then we continue around, nothing over on the right side, and then we have the 6 ohm resistor. And for resistors that are between 2 different meshes, the voltage across them is going to be defined by the sum of those 2 currents. So I'll put plus 6, and then the current going through there is going to be I2 minus I4. And since we're going around the I2 loop, I just define that direction as positive because of the passive sign convention, and I4 is going this way, I2 is going that way. So if we're saying I2 is going in the positive direction, I4 must be in the negative direction. So we finished going around that loop, so that equal to 0. Then we'll do I3, starting down at the bottom left again, coming up this way, and we see we hit this negative sign of the 20 volt voltage source first, so minus 20, and then come up over the top and we see nothing, and then down this way through the 1 ohm resistor, so plus 1, and once again we have 2 currents going through there, so we'll have I3, and then going in the opposite direction of I3, I4. And that, of course, is going to be equal to 0. Then the last loop we have, I4, so once again, starting bottom left, and you can start anywhere you want, of course, that's just where I always start, and working our way up, we'll go through this 1 ohm resistor, so we'll have 1, and this time, since we're doing the I4 loop, I'm going to do I4 as positive minus I3, which is going in the opposite direction. And then we have this resistor on top, so plus 6 times I4 minus, in this case, I2 is going the other way. And if you had drawn these meshes so that they're going in the same direction, they would both be positive, but that's not what we did here. So we just have to be consistent with what we defined as our loop directions, and then everything will work out. And then last side, the right side of I4 loop is just going to be plus 2I4, and that is equal to 0. Now we see that we have 4 equations from our 4 meshes, but if we look at the number of variables we have I1, I2, I3, I4, and this VC that we defined. That's 5 unknowns, and we only have 4 equations. So we have to be missing something because we can't solve a set of equations with more unknowns than equations. So what we need to look at is there any information in the circuit that we didn't use? We didn't use Vout, but we can find that later. That doesn't come up in any of our equations here. But we also didn't use this 2 amps right here. So that 2 amps is this current source, so we know the current going through this branch of our circuit is always going to be 2 amps no matter what, because we have an ideal current source. And the current going down through that branch is just going to be this I1 going this way and I2 going the opposite way. So we can say that I1 minus I2 is equal to 2. So now we have 5 equations with 5 unknowns, and we can just solve those. So I'm going to just move those down here so we have some room, and I'm going to solve these using the matrix method. So I will draw out my matrix, which I know is going to be 5 by 5, and then I'll have my unknown matrix, which is going to be 5 tall, and that's going to be equal to the answer matrix. My unknowns are going to be I1, I2, I3, I4, and VC. And those are all the unknowns we have in our equations. And then we can just start filling in each equation into each row. So looking at the first equation, it looks like we have 7 I1s. 5 plus 2 is 7. And we don't have any I2, and we don't have any I3, and we don't have any I4. But we do have 1 VC, and that is all equal to 0 on our constant side. Then looking at the next equation, we have, look at the number of I1s, we don't have any. How many I2s do we have? Looks like we have 3 plus 6, or 9. So no I1s, 9 I2s. Looks like we don't have any I3s, so I'll put another 0. And we're going to have 6 times the negative 1, so negative 6 I4. And for VC, we have negative 1. Then going to the next equation, this time I1, once again, 0. I2, looks like we don't have any. I3 is just 1. I4 is negative 1. VC is 0. And then on the other side, we'll have to move this 20 over to the right, so it's going to become a positive 20. And I forgot to fill in the right side over here. We don't have any constants in the second equation, so that'll be a 0. Then on to the next equation. I1, looks like we don't have any I1. I2, we have this 6 times negative 1, or negative 6. I3, looks like we just have negative 1. And I4 will have 1 plus 6 plus 2, or 9. And VC doesn't show up in this one. And this one doesn't look like it has any constants, so we'll just have a 0 over on the right. Then for the last equation, real simple one, we have 1 I1 minus 1 I2, no I3, no I4, no VC, and that's equal to 2. Then we can solve this matrix problem using MATLAB or any calculator or other tool you might want to use. And for the sake of this video, I'm just going to skip over that. Jump straight to the solution of this matrix problem. So that is that I1 is 2.087, I2 is 0.08696, I3 is equal to 22.56, I4 is equal to 2.565, and VC is equal to negative 14.61. And this is all very good, except for the problem tells us to find the voltage V out, not any of these values. So what do we do all this work for? Well, if we come up here and look at what V out actually is, we know that V equals IR, And the current going through this resistor here is just I4. So Vout is equal to I4, and the resistance is 2. So I4 times 2, and below we saw that I4 is 2.565, so 2.565 times 2, and we'll get that Vout is equal to 5.13 volts. And that is the solution to this problem. I think I'm going to make another video on this problem, solving it with nodal analysis, but this one's just the mesh analysis, and we can see that after a few systematic steps, we get to our answer. Thanks for watching.